Hello friends and comrades, brothers and sisters. This is the Barker paper. We've been doing the 2012 extension 1 from semester 1. And it's an integration question. And we've got this curve here, y equals cos of x. So that's this one here starting at y equals 1 and going down. And y equals sine of 2x, the one that's just on top here. And we've got to find the area of the shaded region in between these two curves. So that's basically the question. So I'll just read it out though. The diagram shows the graph of y equals cos of x and y equals sine of 2x between 0 and pi on 2. The two graphs intersect at pi on 6. So this shaded region starts at pi on 6 and goes to x equals pi on 2. So just this region here from pi on 6 to pi on 2 is what we're interested in, and calculate the shaded region. So what I'm going to do for you is I'm going to just show you two different methods of doing it. The reason I'm doing this is because I remember Mr. Rundle, the head of mathematics at Barker, once said that it's better to be able to do one question 5 different ways than 5 different questions the same way. And I really believe in that, because every different method, it shows you something different, a different facet of the question, and just gives you a better understanding of things. So the first way we're doing things is, what we're going to do is we're going to say, okay, to find this shaded region, we're going to find the area under y equals sine of 2x. So this region here, this whole area here, the one that I've just highlighted in green. And then what we're going to do is we're going to minus the area under the cos of x, which is this area. Beautiful. And then what's that going to do is we're just going to end up with this shaded region. So I've written here the shaded area equals the integral from pi on 6 to pi on 2. So just this region here of sine of 2x. So that's this top graph. So that's the whole one, the whole green one that I've done before. So that's the combined area down here. And then we're minusing the integral from pi on 2 to pi on 6 of cos of x. So that's just this red area here. So I explained earlier what I meant graphically. This is what this is like the algebraic way of saying what I just said about how we're getting the green area and then minusing the red one. Beauty. So that's one way of doing it, and to me that makes a lot of sense. But the problem is, it's computationally, I mean, like doing the calculations, it is a bit laborious, because you've got to integrate this and then sub in this and then sub in that, and you've got to do 2 integrations. Whereas in this one, you've just got to sub in your limits just once. And so I'll show you the basic principle behind this question. So what we're doing is, I've drawn the graph of sine of 2x minus cos of x. And I'll briefly explain why the graph looks like the way it does. So imagine, it's all to do with y values. So sine of 2x, so this is the graph I'll just write that we wrote down below. Sine of 2x minus cos of x. What I'll do is I'll just get a bigger font there, hey? So what we're saying is sine of 2x minus cos of x. So at this point, x equals 0. Sine of 2x is 0 and cos of x is 1. So the point is going to be minus 1. At this point here, sine of 2x is some value, and y equals cos of x is the same value. So it's going to be 0, because this y value of sine of 2x minus the y value at cos of x is just going to be 0. Beautiful. And at this point here, both of the graphs are 0. So sine of 2x minus cos of x at this point here is 0. So going through all these 3 points here, it's no surprise that's where we get this kind of graph like what I've drawn below. And so that's where we get this figure from. And just to give you a bit more of an understanding, so the way this graph works, sine of 2x minus cos of x. Say this point here, we'll call it 2, right? Who knows if it is, but and say that this height here, the difference between sine of x and cos of x, this blue bar here, say that is a half, that height there. Then this graph down here, which is sine of 2x minus cos of x, say this is the point 2, then this distance here would also be a half. So that means that this area here, this pink region that I've shaded, between pi on 6 and pi on 2 of sine of 2x minus cos of x, will be the same, exactly the same area as this shaded region just here. Beautiful. So what we're going to do now, so we're going to find the area, find this area here, which is the integral from pi on 2 to pi on 6 of sine of 2x minus cos of x dx. Beautiful. So now we've just got to do the calculation. So we're going to integrate. So the integral of sine of x is minus cos of x. So, but because we've got a 2x, what I usually do is say, okay, we leave the 2x the same. And then when we differentiate this, like, so we're going backwards and doing the opposite of integration, this 2 is going to come out. So we need to put a half here. So when we do differentiate this, it's going to go 2 times a half, and then I'll get minus 1. And then when we differentiate minus cos, we'll get sine. So that's cool. And then the integral of minus cos is, of course, minus sine x. Beautiful. And then we've just got to pop in our limits of integration. Pi on 2, sorry, and pi on 6. Cool. Beautiful. So now what we're going to do is we're just going to chuck in these values. So I'll just do a juicy little red. Cool. So when we put pi on 2 into here, what that's going to do is, of course, 2 times pi on 2 will just be pi. So we'll get minus a half, let's do brackets first, minus a half cos of pi. Cool. And then we're going to put minus, so minus sine of pi, I'll just put it down here, minus sine pi on 2. Cool beans. And then remember, we've got a minus, then we've got to sub in this bit. I always used to forget this when I was at school. So it's a real trap for young players. So we're going to put pi on 6 into here, and then we're going to times it by 2, so it'll be 2 pi on 6, which is, of course, pi on 3. So we're going to get minus a half cos pi on 3. Too easy. And then minus sine of pi on 6. Cool. Beautiful. So now let's think about it. So I've just drawn this little triangle down here before we've started, just to give you an insight as to what cos of 60, which is another way of 60 is pi on 3, and this is pi on 6, just to help us with our exact values of when we put these things in. So what we're going to do, so it's going to be minus a half. Now cos of pi is minus 1, so you can just pop that into a calculator if you don't believe me. And then minus sine of pi on 2. So sine of pi on 2 is minus 1. Cool. And then we're minusing, so we'll pop a little minus sign. Cool. So cos of pi on 3. So pi on 3 is, of course, 60 degrees. So cos of pi on 3 is cos of 60, which is a half. So if that's a half there, then we're going to get minus a half times a half, so it's going to be minus a quarter. Beautiful. And then minus sine of pi on 6. So pi on 6 is 30 degrees, of course. So that's going to be opposite over hypotenuse, so it's going to be a half as well. So minus a half. Beautiful. So we've got bloody fractions coming out our ears here. So we're going to get minus a half times minus 1, so it's going to be a half. So this will be a half, because it's going to be minus a half times minus 1. Minus 1 here. So we're going to be left with minus a half out the front. Too easy. Minus, and then this is going to be, in the brackets here, minus a quarter minus a half. So that's going to be minus 3/4. Check minus a quarter minus a half. Yep. Beautiful. And then we're going to get minus a half plus 3/4, because year 7 directed number issues, minus and a minus is a plus. Too easy. And now remember, so we're just going to do a common denominator. So I'm going to write this as minus 2 over 4. So now we've got a common denominator, a plus 3 over 4. Beautiful. And that is, of course, 1/4. Beautiful. Units squared, I would write, because remember, we're trying to find the area of this shaded region. And we definitely know it's a positive area, because like here it's a positive area, and we got a positive number. So if we got a negative number here, we would have known we made an error at some point, but we haven't. So hope that was clear. What we could have done is we could have done this calculation from here, and integrated both things, but I've only decided to do it once. So you've just got to pick a method that works for you, and whatever you'd prefer. But I hope that one was clear, guys, and I'll see you in the next one, fellas.